The purpose of this experiment was to create a program to analyze the star's motion in order to find the net force acting upon the star for a given set of data. Included in the dataset was a series of x and y positions, the star's mass, and a time period of 1 day. The net force acting upon the star was due solely to a black hole. The only known information for the black hole was a position, and using the results of the analysis, the mass was to be calculated. Newton's law of universal gravitation was applied to find the black hole's mass of 3.77 times 10 to the 31st kilograms. The model was created using a starter program given. The star's mass was changed to 2.8307 times 10 to the 27th kilograms, which was given in the problem. Delta T was also changed to represent 1 Earth day, or 86,400 seconds. The data of corresponding x and y positions was put in a file to be iterated through to calculate the changes in positions. These values were then used to estimate an initial and final velocity, and those values were then used to estimate an initial and final momentum. Given changes in momentum, F-net could be calculated along with the components of F-net, which are F-net parallel and F-net perpendicular. The results of the analysis were then used to calculate the mass of the black hole. In order to do this, an arbitrary time was chosen to analyze at the 1,123,200 second mark. At this point, any time could be chosen as long as it wasn't zero, as you need a non-zero value for the net force. Then, a distance vector was found by subtracting the position corresponding to the time chosen from the position of the black hole, which was given. The magnitude of this vector was then found. Using Newton's law of universal gravitation, we then had F-net as estimated by the program, the mass of the star, the magnitude of the distance vector, Newton's gravitational constant, and we could solve for the mass of the black hole. In doing so, the mass was found to be 3.77 times 10 to the 31st kilograms. What does it mean? F-net affects the motions of a system. In other words, it is the cause of motion, while dp dt describes how an object moves, or the effect of the force. What if? There wouldn't be a difference. If the motion of the observed star is unchanged, then all data, both given and found, will remain the same. Therefore, you would be solving for the same mass.